Rightio, back with Larry and Dan. We're going to talk about temperatures when filling and using BA sets. You okay with this, Larry?
I'm hoping to be, Dan.
All right, give it a crack, mate.
Let's get into it. Obviously, we're going to take a volume of air from the atmosphere and put it into there, and we're going to take this much and make it into this much. So during the compression factor, there's temperatures impact. It's important to note that in the environment, in this room, there are a number of components in the air, one of which is water vapour. The amount of water vapour that can be held in air is governed almost entirely by temperature. So as we fill a cylinder, if it's hot environment, there's likely to be more air, so you need an effective demoisturiser in your filling system. Mm-hmm. And I note that you guys have a refrigerant freezer attached directly to your compressor, and that is the best system. That's physics at work, and that relates to what I just said about temperature. The higher the temperature, the more moisture can be held in air. So if you take the temperature component away, all the moisture condenses out as fluid and only the dry air comes through. And that's what you're doing here very wisely. Now, as we compress the air into the cylinder, the molecules of the air collide with each other, and as the more pressure we put in, the more rapid the collisions, the higher the friction coefficient, the higher the temperature. So it gets quite hot, and for every 1 degree C is costing us 1 bar in pressure. So if we fill this to 300 bar, as your system would do, and it's 30 degrees or 45 degrees C inside that cylinder, and it drops back to 15 degrees C, which is, they choose 15 degrees C as the charging temperature because that's about the average surface temperature of the world, the whole world. Water's average temperature is about 14 degrees, only 1 degree difference between the air and the water. So when it cools down to 15, we would have lost 30 degrees and therefore 30 bar. So to be down to 270, we'll have to top it up, fill it up again. 15 is the average for the world?
Yes. I'm going to Google that after this.
You do that, sir.
Okay, continue.
All right, here's your tester. The inverse of that, when we take this air out of the cylinder and expand it, it cools off. And most people note that. And I had a very good question today about, we understand the temperature. If this cylinder is in the boot of your car or the back seat of your car and you go for a counter lunch, and all the windows are closed and you're in North Queensland and the temperature heats up to 60 or 70 degrees inside or hotter, 100 degrees. Sometimes you can't even hold the steering wheel of the car. Well, this cylinder's subjected to the same temperature. The pressure increase activates the burst disc.
Yep.
And you lose all your air, blow the seals on your car doors. It's quite dangerous. You could blow a window out, or it's not good for anything. Now, inverse to that, when we expand the air as we take it out, and in answering the question that I had, how come firemen don't experience the same problem when they're in a fire where the temperature is higher than
much higher,
60? Yeah. Because we're breathing from the cylinder, the air's expanding, and expanding air causes a reduction in temperature. So it cools down, and can cool down by over 30 degrees C. So on a 25 degree C day out in the sun, you would think, well, nothing's going to freeze here. But you look at your cylinder valve during use, your pressure reducer, part of your hose, you'll see ice on it. Now that ice is not coming from inside the cylinder, it's coming because of the physical aspects of expanding air, cooling down the metal in the valve, cooling down the metal in the pressure reducer, and cooling down the rubber and liners in the hose. And when it does that, we spoke about the moisture in the atmosphere.
Mm-hmm.
The moisture in the atmosphere, which is close to the valve, gets colder than the surrounding air, and that moisture then condenses, forms bubbles on the metal. The metal's very cold, so it freezes. And that's why we see the moisture on there. And if you rub that, by and large, most of it will come off because it's a dust type freezing. And if there's any moisture in the system, and we've got to be very conscious of moisture in the system, particularly in the pressure reducer and demand valve.
Absolutely.
And it's not a matter of will it freeze, it will freeze.
Yeah, so if we've got moisture inside our cylinder and it's going through our lung demand valve, it's going to freeze at some point and you're in a bit of trouble.
Yes.
Right? So when you see the valve and the pressure reducer and the hoses, we say freezing, it's not. That's just moisture from the atmosphere attaching itself, and it's a sprinkle of ice on the outside.
Yes.
Cool, but that's dangerous when it's inside the cylinder.
Yes,
which is why we're going to do those air quality tests every 3 months, because we work out how much moisture is in the air.
Yes, and you don't want any moisture in there at all.
Perfect.
Because a dark, moist environment is also conducive to bacteria.
So, lesson here, I guess, when my students keep saying to me, my stuff's freezing, it's not. It's just a sprinkle of ice on the outside. It's the moisture in the air. Push on.
Yeah, and it's caused by the metal cooling down, caused by expansion of air. It's a physical property of the world.
Yep.
Compression causes heat, expansion causes cooling.
Easy. All right, if you need anything, more information, clarification, reach out to ISH24 and I'll help you out.
Every time.